Now, what's been kind of neat is that so far, if you've been watching other related videos, we've been talking about polynomials that look like, 3x to the 5th plus 2x to the 4th minus 5x squared plus 7. And those are totally legit polynomials. But we can actually have polynomials that involve more than one variable. So we could have 3x to the 5th y plus 2x to the 4th with no y in it, and a minus 5x squared y to the 14th, and then a 7y squared and a minus y plus 8. And we can have something like that. So as you can potentially remember, if you watch some of these other videos, there are some basic rules we have to have for something to actually be a polynomial. These are our rules. The exponents had to be positive integers. The coefficients could be anything, the coefficients being the thingies in front of the variables, and they could have a constant term. There was nothing in the rules that said we could only have one type of letter or variable in the problem. So that just means that everything that we've learned so far with polynomials using just x's applies to things that we do with polynomials with x's and y's, as long as those exponents are positive integers, and we have a constant term. So pretty much anything we have been doing thus far, we can continue to do. So I'm just going to give you a couple of examples to work out and get some practice, and you should be good to go. Okay, so again, take a look at these problems. They should be very similar to what you theoretically have done in things that just had one variable. It's the exact same process. So just pretend the y is a 12 or a 7 or whatever. Let me leave it as y, but just treat it like you would any other number and go ahead and solve these problems like you would. So again, pause the video, see how far you can get, and then come back and unpause and we'll work through them together. So, assuming you've done that, let's see what we can do now. All right, so we can't do a FOIL or anything fancy on this. We just have to do kind of a straight up that this x squared wants to get multiplied by everything that follows, and the 2y, the negative 2y, wants to get multiplied by everything that follows. So that means we have x squared times 3x squared plus 2xy plus 7, and then plus the negative 2y times, again, that 3x squared plus 2xy plus 7. Okay, so again, that x squared gets multiplied by everything that follows, and the negative 2y gets multiplied by everything that follows. So the x squared gets distributed now across each one of those terms, and the negative 2y gets distributed across each of those terms. So I've got x squared times 3x squared, x squared times 2xy, x squared times 7, negative 2y times 3x squared, negative 2y times 2xy, and you can't see what I'm doing anymore, and negative 2y times 7. Okay, go ahead and move this guy down some more. Go away. All right, so we've got this lovely, in no way intimidating thing. I think half of the problem with math is just getting scared. Oh my gosh, I dropped a thingy. Another problem is totally messing up. Make sure you caught that. If you were wondering what I was doing, I was just not paying attention. I was getting all excited about science. So make sure you got that. That was a very, very crucial stuff. I think I said I just didn't write it. Maybe I didn't say it or write it. In any case, I found it, so that's all that matters. All right. So we have x squared times 3x squared. So we have x squared times x squared. So that's x to the 2 plus 2, so that's x to the 4th. All right, then we have 2x squared times x to the 1st. So that's 2 plus 1, x cubed, and then a y. And then x squared, or 7x squared. All right, then we've got a minus 6, x squared y. Negative 2 times positive 2, still negative 4. X, y times y is y squared. And again, if it took you more steps to get there, that's fine. If you're not sure what's going on, just keep writing stuff out. That's never harmful. And it actually looks like all of those are unique terms. Nothing can be combined because we have a fourth term, a cubed term, a squared term without an x, and without a y, and a squared term with the y, so I can't combine them. I'm going to say that again. This squared term has no x, has no y. This squared term has a y, so I can't combine them. And everything else is unique, so I'm actually done. That's the end of that. All right. So let's try this next one. See how that goes. and 2 go away. All right? So I have x minus 3y squared. Now, if you remember, we had something that said a minus b quantity squared was equal to a squared minus 2ab plus b squared. So I'm just going to use that because I can. So it's first thing squared minus 2, first thing, second thing, plus second thing squared. First thing, second thing. Ooh, whoa, 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 girl, whoa, whoa. 3y. Whew, that was scary. Okay. You can tell I'm getting excited. Math, yay! All right, so that's going to be 2 times 3 minus 6xy. And then remember that this is the whole thing here is squared. So it's x squared minus 6xy. And then remember that that has to be 3 squared times y squared. So that's going to give me 9y squared. All right, uno más. Now we're done for a while. So again, if you'll recall, we had a formula. And if you didn't do the formula, but you still get the right answer, good. This is just supposed to be a shortcut, and I'm just trying to show you how to do the shortcut because we've done them the long way a lot. So it's going to be first thing squared plus 2 first thing, second thing, plus last thing squared. All right, so first thing, and then second thing. Okay, so again, remember that that whole 2x, that whole quantity is squared. 4 times 7 is 28xy, and then the whole 7y squared. So again, I'm just going to write this out. That's 2 squared x squared and 7 squared y squared. So your final cleared answer for this one's going to be 4x squared, 28xy, 49y squared. Woo! So have some fun with that.